global, new product design and development. Object orientation. Object-oriented programming, OOPS, used parametrically to represent a product structure. The more important aspects to OOPS being used in such cases are: the code object represents the physical object. Objects have methods, how they work. Objects hold data with them. The objects can send messages to each other to supply data or ask a question. Within these methods, within the objects can set flags when asked a given question. Such systems can be used to alter the program flow depending on the order of the questions asked. If I want a ship which carries lots of cargo cheaply, it will be short, big in the beam, and be slow with a small engine using not much fuel. Product structures will be meta objects showing the part relationships. So here we have an object-oriented system representing a locomotive, and such a system for design inputs of tractive effort, continuous operation and AC/DC operation. So for instance, if the length of the train changes, all other dimensions related to that will change as well. The DC motor powering the train will draw so much current. The copper bus bar carrying the current will be selected from a list. The known section of the copper bus bar will then be bent to a known selected bend radius. The total weight of the train will be calculated, and the extra weight required to put down the tractive effort will be calculated in the final design. Such an object-oriented product model design system has to be an accurate tendering costing system. If you tender too low in one-of-a-kind production, you get lots and lots of business and go out of business. If you tender high, you get no business and go out of business. Your tendering cost must be accurate. This requires a great amount of detailed design at the tendering stage. So it's a tendering costing system. It's a detailed design system. It has to be able to deal with engineering data management, represent the product structures, and deal with parametric part numbering systems. Such systems, for example iCAD, has also been used for parametric double glazing and conservatories. So a salesman comes to your house with a catalogue and a computer. You choose the type of conservatory style you want. He then measures your house, and then the parts for the build a conservatory made to measure for your house are done at the factory, and the conservatory is built. This is done using object-oriented product models. So the iPhone, designed by Apple in Palo Alto, California, but made in China. This requires object-oriented product design and object-oriented factory layout simulation. Since the factories layouts are only used for a short period, and the product is being made in factories in several places, all the factory layouts must be coordinated such that the product is made correctly right first time, and that requires object orientation. So they've got to minimise total global costs yet provide good customer service. They have the latest short-lived model, needing the right components on a short lead time. Rapid technological change requires global market planning and global design control. So Intel brings out a new CPU and board specification 3 months to market. Canon have a new laser printer engine, and like a Gold Star, are bringing out new flatter screens. IBM want a new product line with new CPUs, new screens, new printers and RAM. In order to do this, they have to communicate their design requirements, generally in the shape of a solid model, to their suppliers, so that suppliers can build around them accurately and be right first time. Example global product design control systems are Windchill and Tecnomatix, now owned by Siemens. Mass customized consumer products. Companies wishing to differentiate their offering to the market will wish to provide such services, since where there is differentiation, there is generally a scope for a healthier profit margin. A good example is that of custom built bicycles. Cannondale, USA offer a bespoke made-to-measure service on the top road racing frame, where the key customer dimensions and colour scheme are taken by an authorised dealer in any of 66 countries, then sent to the Cannondale plant, where a near unique frame will be made in the advertised delivery lead time of 6 weeks. So here we have a frame with dimension A, dimension B, angle C and dimension D. Offering a customer menu selected range of fittings might further improve the service. However, applying only the frame probably induces such a large network of specialist dealers to participate. Finally, global transnational product design, development, manufacture. So here we have a picture of a Black & Decker drill, which is a solid model produced using Catia CAD solutions, which is owned by and developed by Dassault Systèmes. And below that we have an extract or a screenshot from the Tecnomatix demo, where they have in the second diagram an electronic bill of parts, whereby an electronic bill of parts can be developed in the main manufacturer and communicated with its changes out to the suppliers, and the parts to be required in the product are held electronically. This all requires global design control.